Alright, let's suppose we have a right triangle, and let's suppose one of our other angles is 45. Well, this remaining angle would have to be 45 because 90 plus 45 is 135, and 180 minus 135 is 45. So this angle is also 45 degrees. If you think back to the isosceles triangle theorem, it says that if you have two angles that are congruent in a triangle, then the sides across from them are congruent. So we know that if we call that L, one of our legs in the triangle L, then in this specific triangle, this is also L. Now let's see if we can come up with an expression for this third side. It's a right triangle, so we can use the Pythagorean theorem. Across from the right angle is always our C. So for now, we'll let that be C. So we got C squared equals A squared plus B squared. That's the Pythagorean theorem. Right now, we're just letting it be C, and we're going to try to solve for C. In place of A, we can put L, because we're using that to represent one of the legs of the triangle. If in place of B, we can also put L. Now let's see if we can solve this for C. L squared plus L squared, that's one of those plus another, that's 2L squared equal to C squared. Now to get rid of squared, we square root both sides. If you square root the left side, you have to square root the right side. Only the positive square root makes sense here because we're looking at a side length in a triangle. Now the square root of L squared is L. Square root of 2, well, that's just the square root of 2. It's an irrational number. We're not going to approximate for it. So we can say that this hypotenuse is the leg length times the square root of 2. That works every time you have a 45, 45, 90 triangle. Whatever your leg length is, those legs will be the same, and your hypotenuse is the leg length times the square root 2. Memorize this 45, 45, 90 triangle.